Hello everyone. In this video we're going to be working on the week 4 notes in your workbook, which begin on page 33. So go ahead and flip to that and we're going to just jump right into graphing with this week's notes. So we're going to start with graphing linear functions. So linear functions are always going to follow this format that I've just highlighted right here on the top of your notes. Y equals mx plus b. The y and the x represent your axes. So I'm just going to jump ahead real quick to show you that this right here, the horizontal axis, is your x-axis, and the vertical axis is your y-axis. If it helps you to remember, y to the sky, that's going to be your y-axis. Okay, the other two letters in that format are M and B. Let's start with M. M is right here and it's representing your slope. So slope is also known as your rate of change, or in other words, the increase rate or the decrease rate, whether your line is going up or down. So it's really just your rate of increase or decrease. Okay, that's your slope. Something I didn't mention yet, but we're going to go over it right now, is this right here, rise over run. So rise is your top number, run is your bottom number, which might not make sense right now, but I'm going to give you an example, and hopefully that'll help make sense of this rise over run idea of rate of change. So this first example in the graph below, you'll notice each dot is connected to form this line. Now to get from point to point, you rise 4 boxes and you run horizontally 3. The reason they use run is because you run horizontally and rise is going up. We'll get into that a little bit later, but for now, rise is up, run is horizontal to the right. And you'll notice it follows that pattern the whole way. Then you rise another 4, run 3, rise another 4, run 3, and so on. That is your constant rate of change that will ultimately get you all of the points that make up this line. Okay, now this line and this graphing process needs to start somewhere. That's where the letter B comes in. So B is right here. It's also known as your y-intercept, or in other words, where the graph crosses the y-axis. If you look at your graph, remember the y-axis is the vertical one, so the point where the this line right here crosses the y-axis is this point. Okay, so that's going to be your y-intercept, because that is where your y equals mx plus b line crosses the y-axis. That makes it your y-intercept. Okay, this is really just like an introduction on vocabulary for now. I'm going to get into in the next example how to actually graph this, but that's how you kind of interpret the pieces. The slope is your rate of, for this one, increase, because your line is going up. When you read it from left to right, it's going in an upwards direction. And when you start graphing it, or where it just crosses the y-axis, you can look at it both ways, is this point right here on the y-axis, where your graph crosses the y-axis. So because your slope is rise over run, if you look right here, slope is 4 over 3 because it was rising 4 and then running 3. So that's where the slope comes from, the 4 over 3. The y-intercept is circled in red right here, and that is at a value of 5. It's right between 4 and 6, so that makes your y-intercept 5. So if you take those two numbers, you have your y equals mx plus b format, but your slope is 4/3 and your y-intercept is 5. That'll create my equation y equals 4/3 x plus 5, which you'll also see written right here. So that's what the pieces of the y equals mx plus b represent, your rate of increase or decrease depending on whether or not you have a positive or negative slope. And then b represents where you hit the y-axis. So we'll just hit this as well, positive slope, because this one is going in the upwards direction. Okay, now like I said at the very beginning, in order to graph any line, you have to be in that y equals mx plus b form to even start. So that's what this right here is saying. You must be in y equals mx plus b form in order to graph it. I'm sorry. There are two different methods that I'm going to go over with you for question 145. Okay, so here's the equation we have to graph. It says y equals 2/3 x minus 2. Now picture that coming from your y equals mx plus b, and just figure out what m and b are. So that's your first method that I'm going to go over with you. It's just called the m and b method, where you figure out what m is, you figure out what b is, and you graph it based on the information I really just went over with you at the top of the notes. Okay, so for this one, picture where m is. M is right in front of your x. In this case, that is a fraction, so m is going to be 2/3. And then in that y equals mx plus b form, that plus b is tacked onto the end. It's the number that's not with the x. M is always going to be attached to the x. B is going to be the number by itself. In this case, that number by itself is a -2. You always have to take that symbol in front of it. So b is a -2. Okay, so now that we know what m and b are, we're going to use this m and b method to graph the equation of this line. So it even tells me right here to start at B, then do the rise over run. So B, remember, is your y-intercept. You're going to graph it on the y-axis. So my point is going to go right here at -2 on the y-axis. So I took care of the start at B. From that point, you're going to follow this rise over run concept using this fraction, 2/3. So because the 2 is on top, that tells me I'm going to rise 2, and then I'm going to run right 3. You are always going to run right, and then the 2 on top tells me to rise. So from that -2, I'm going to rise up 2, right 3, up 2, right 3, up 2, right 3, and so on. So up 2, right 3, I count up 2, right 3, and my point goes here. Okay, and so on. You just count up 2 boxes and then right 3. Now, a fun little fact about graphing lines is you technically only need 2 points to graph a line. If you have a point and a point, you can connect them to create a line. Now, we've already made 4 points for this line. I want you to now go in the other direction. What will help you for some of our future graphs, and I'll explain that to you once we get there, is having, like, the more points, the better. I think it's in the next week of notes that'll really come up, but it's better to just get in the habit of it now. So my pattern here was to rise 2 and run 3. So I went up 2, right 3, up 2, right 3. Something else that you can do is the complete opposite to follow that linear pattern in the other direction. So instead of going up 2, right 3, you can go down 2, left 3, and you'll get the same pattern. So from this point again, my y-intercept, I'm now going to go down to left 3. And notice it just follows the same linear pattern, but in the other direction. Now, something that I think might be helpful to you is when you are done graphing something, when you're done graphing a line, I know it sounds kind of silly, but it should look like a line. Sometimes people mess up their slope and they accidentally end up 1 point above, and it doesn't look like a line anymore. So just be aware of that. If your graph doesn't look like a line and it's supposed to be a line from that y equals mx plus b format, something went wrong. Okay, so just be cautious of that. I'm just going to connect my points. Now, even though my grid ends, you'll notice that my grid goes out to 10 in all directions. Even though the grid ends, the pattern of the line doesn't end. So that's why I have these arrow heads at the end of my graph, because the graph does continue in both directions. If the grid went out to 100 here, I would continue going on and on, up to right 3, up to right 3, until the end of my grid hit. I would never do that to you, though. Okay, so that's method 1, and that's the method I'm actually going to use with you a lot. Method 2 is using the graphing calculator, which you may or may not have done before, but this is essentially how to do it. So you're going to go to the y equals option on your calculator and pull up a table of points. So I'm going to pull open my calculator to start and show you where exactly those buttons are. So I know some of you have an app that might look a little bit different than mine, but the buttons are in the same area. Okay, so this second method is to press the y equals button on the top left. So that would be this button right here. You just press y equals. Okay, you may or may not have something in your graph, in your y equals section. If you do, just hit clear so that everything is cleared out. And my advice to you is if you are someone who has borrowed someone's graphing calculator, you might want to scroll down using the down arrow and make sure all of them are empty. Sometimes people think it's funny to like make a graph down here and you'll never see it and it gives you a lot of errors. So just make sure they're all cleared out while we're at this point. And once you're all cleared out and ready to go, what we're going to do is in your y1, the very top y equals, you're going to just type in the equation. So if you're looking at your note page right now, remember the equation that we're graphing for this example is y equals 2/3 x minus 2. So to type in 2/3, you're just going to do 2 divided by 3. Most calculators, when you type in a fraction, need parentheses around them, so I highly recommend it. Yours might not, but I really don't want to take that chance. Just parentheses around your fraction. The X button is right here, very close to the y equals, up on like the top left area. It has an X, comma, T, then a theta, I think yours has, and then an N also. If you just press it, it'll get you an X. And then minus 2 is much easier, just minus 2 at the end of that. So again, 2/3 is a fraction, so it should go in parentheses. Type in your x and then the minus 2. So this method is kind of cool because your calculator will give you a picture of what your graph should look like if you hit the graph button. So on the top right, I highly recommend your next step if you choose this method is to press graph. So on the top right, you'll see the word graph. Just press that. So clearly you can see my scale is very spread out. Whatever example I was doing before this, I must have been looking at some big numbers. I'm gonna try, I'm just zooming in like you would zoom into a picture right now to get it closer to the scale we have. Remember, it's just a 10 by 10. So that's a lot closer. But that's about what our graph looks like. If you look at the graph we just did in method 1, that's very close to what ours looks like. Okay. If you're using the app, you're going to have to hit the close button on the bottom right. If you're not using the app, you can just stay where you are because you still see your calculator screen. Okay, now hitting graph is a good idea of what you want, but at that point, like let's say I just used that method, you can't just go, whoop, it looks like that and call it a day. You need to actually plot points. So where do you get those points? It's going to be on the table. To get to this table, you're going to hit the button that's called second on the top left, and then you're going to hit that graph button again on the top right. So I'll go back to my calculator. I still typed into my y equals. I'm going to hit second, which is right here, and then I'm going to hit graph again to pull up my table. So second graph, and you will see a table. I know what this table is giving you is on the left a list of x values and on the right a list of y values. So what this means, and I'm going to bring you to the first one of 0, -2. So your table might be all over the place, different than mine. Just scroll up and down to see all of the different points. This table will go on forever. You could literally press down for the rest of your life and it will keep calculating numbers. It's crazy. So what your calculator just did, going back to like a couple weeks ago of notes, inputs and outputs. If you remember that, awesome. It was from week 1. So what your calculator is doing is it's taking the equation that you plugged into it, that y equals 2/3 x minus 2, and it's plugging in every possible x value and giving you the output that's a y value. So what this table is telling me is if we plugged in a 0 to that equation, the output would be a -2. If we plugged in a +1, the output would be -1.3 repeating. Okay, going down a little bit further, if we plugged in a 3, the output would be 0. It saves you so much time, and it's so cool how quick the calculator can just whip up those numbers. Okay, so word of advice, if you do choose this method to graph all these lines that we're going to be doing, you don't want to graph the decimals. Nobody wants to graph a decimal. So if you just keep scrolling up and down on your table, you'll notice there are a lot of nice coordinate points. So how on earth, and look, you can literally just keep scrolling and scrolling and scrolling. It did all of those calculations. It's wild. Okay. You can scroll forever, so how do you know which points you actually want to plot? You can only plot what's plottable, and I know that sounds kind of stupid, but you can't plot these points that I'm looking at right now because the x values are 32, negative 31, negative 30, negative 29, and those values aren't available on our grid. Remember, our grids on the notes only go out to 10 in all directions. So negative 10 through positive 10 are values that I can plot, and none of these values I'm currently looking at have that. So I'm actually going to scroll to negative 10. Okay, negative 10 would be the first nice point to plot if it wasn't a decimal. I don't want to plot decimals, so the first nice point is actually going to be negative 9, negative 8. I can plot that. The point after that's going to be negative 6, negative 6. I scroll down, no decimals, no decimals. So I want negative 3, negative 4 is my next point, and so on, and I'll keep going until I get to, it looks like the point 9, 4 is my last nice point, because the next nice point after that is 12, 6, and I can't plot a 12, because again, I only go out to 10 on my grids. So I keep saying nice point, nice point. What I mean by nice point is it's not a decimal. Okay, so you're only going to plot those non-decimal points. So I'm going to actually take a second to write out that table so I don't have to keep flipping from screen to screen. And hopefully this will also help you kind of see what we're doing here. So remember, the first nice point was negative 9, negative 8. After that, the next couple points weren't good. I want negative 6, negative 6. That was the next one with nice whole numbers, no decimals. Okay, and then continuing on, just copying down all of those nice points. I knew I was going to do it. Go 3, 0, 6, 2, and 9, 4. Okay, so those are all the nice points from the table on my graphing calculator. Okay, so how do you take that information and actually graph it? Remember, our axes, horizontal is x, y is the vertical one, y to the sky. So if I'm plotting this first point, it means that when x is negative 9, so I go on my horizontal x-axis to negative 9, that's this point right here. I don't put a point there though. I then have to take that negative 9x value and also go to where y is negative 8. Y is negative 8 right here. So I need to just match up those two values, and it tells me that my 1 point that I'm making is right here. You know, obviously you don't want all this mess, but I'm just trying to show you visually what I'm talking about. Now something that's kind of cool, and you'll notice at this point, is we're getting the same graph. Different method, but it's going to get you the same graph. Okay, so my next point, negative 6, negative 6, means on my x-axis I go to negative 6, on my y-axis I go to negative 6, and I put a point where they match up. So take a second, if you prefer this method, to graph the rest of those. So negative 3, negative 4 would be here. 0, negative 2, and so on. See, now at this point, like actually graphing all those points, I think is a little bit tougher. Not that it's hard, but it's a little bit tougher than just going up 2 over 3, up 2 over 3. I'd rather just count boxes than try and find numbers and mix and match. Okay, but if you plot the rest of your points, this is ultimately the graph you're going to have, and you would just connect them like we did with the last method and an arrow at the end, because as you could see by the table, oh wow, by the table on our calculator, it did continue on forever and ever. And so like I said, I'm going to continue on with this rise over run M&B method for the rest of the notes. If you don't prefer that, just do it in your graphing calculator and then just make sure you're getting the same graphs as I am. that'll be perfectly fine. All right, scooting right down to next example, 146. This is the last equation we're going to graph, but we will be doing more practice with graphing lines coming up. So this equation is y plus 2x equals 7, and it says using method 1 or method 2. Like I said, I'm going to use method 1. If you want to use method 2, go for it. Just make sure you have the same line that I do at the end. All right, now the big problem with this example is it is not in the format we need it to be to graph it. Remember what we talked about up here. You must be in y equals mx plus b form to graph any line, and this one is not. So this is where those literal equation skills come into play. You have two variables in this equation, and you need to solve it for y, because if you notice that y equals mx plus b form has y by itself. So your goal is to get y by itself. Now right now y is not by itself. It has a plus 2x in the way. How do you undo plus 2x? You're going to subtract 2x from both sides. So I do minus 2x minus 2x. Remember what I mean by both sides is both sides of this equal sign. Okay, and that works out awesome because 2x minus 2x cancels. So my y comes down, my equal sign comes down, and then remember what I told you with literal equations? You bring this down how you would read it. You can't actually combine 7 and 2x. They're not like terms. So 7 minus 2x is going to be brought down as 7 minus 2x. So that's very colorful. I'm just going to simplify it. I have y equals 7 minus 2x as the equation that I need to graph. Now, that's, believe it or not, mx plus b form. Even though the x comes after the b, it's still the right format. So you can rewrite it, but you have to be careful with your negatives. I'm going to leave it like this because I feel that just based on teaching it a lot of times, people prefer to leave it like this. But again, like I told you, I'm going to use that m and b method. So now that I have y equals mx plus b, I need to figure out what m and b are. So it's mx plus b. So that tells me that the number in front of x is m. In this case, m is going to be -2. It's the number in front of x. So m is, what is that, the fourth time I've done it this time? Look at all these notes we've done. We're doing great. Okay, so m is the number in front of x, which in this case is a -2. And b is the number by itself, which is going to be the 7. So b is 7. Okay. If you flip-flop the order, it would look like this, -2x plus 7. This is one whole term and it needs to be brought down here, and same thing with the 7. It's a +7, so that would move there. A lot of people don't like that, but if you do, that's what that would look like. And m is still -2, b is still 7. Okay, so with m and b method, you start by graphing 7 on your y-axis. So I'm going to put a point on +7 on my vertical y-axis. And then from there, you have to do rise over run. Now, there's a problem with this one. My slope is -2. And rise over run is a fraction. I'm supposed to have a number over another number. You always, always, always want your slope to be a fraction. In this case, it's not given as 1, but you can turn any number you want into a fraction by putting it over a 1. -2 over 1 is the same as just having a -2. We don't write it over a 1 because that's complicated. There's no need for it except for when you're doing slope, because you want it to be a fraction. Now this one's also a little bit tougher because of the rise over run concept. Like I told you in the last example where we did the m and b method, you will always run right because your denominator will always be a positive number. If you look at the -2, that's telling me to rise a negative number. I know it seems stupid to use the word rise because rise means up, but if you're rising a negative number, it means you're going to rise down. I know that sounds crazy. Rise over run is just supposed to help like jog your memory to show that this is a vertical change on top, and then it's a horizontal change on the bottom. But then you have to look at positives and negatives. If you're rising a -2, that means down. Whereas for these ones, we were rising a +2, so that was up. And are a little bit different. And again, this is not the last example we'll do. You'll see a lot more practice with these. But if it's a negative number on top, it means rise down. And for all examples you're going to see, we're always going to run right. So that's a nice way to remember. Your denominator is always going to be positive in this course. So we're always going to be running right. So that's why I tell you that. So this one from 7, I'm going to go down 2, right 1, down 2, right 1, down 2, right 1. Just take a second to give that a try. Down 2, right 1. Just follow that same pattern. And then remember, for next week's notes, what I told you is you want to put as many points on here that'll fit on the grid as possible. So the opposite of down to right 1 is up to left 1. So I can also go from 7 up to left 1 to get that final point up there. I know it seems like you can graph it without it. I promise in the notes to come, you'll want as many points on your grid as possible. And once you have all those points, just connect them and put your arrowheads on the ends. If you need more time, pause the video, but just a quick little summary about graphing lines. You have your slope and you have your y-intercept. When you're graphing, you want to start at your y-intercept, and then using rise over run, you're going to rise up if you have a positive numerator, and you're going to rise down if you have a negative numerator. But your denominator in this course is always going to be positive, so it's always going to run right. Something else that'll help you check at the end, notice this graph has a negative slope because it's going down. When I read it from left to right, it's pointing down. So that means it has a negative slope. That'll only work if you go rising down. Whereas this one up here had a positive slope, and reading it left to right, it ended up going in the positive direction. So hopefully that helps a little bit. We are going to, like I said, do more practice in these next few examples, but we're going to start looking at inequalities. So remember our inequalities, we have less than, greater than, and we have less than or equal to, and greater than or equal to, our 4 inequality symbols. So I don't know if you remember, when we were solving inequalities, you followed the same steps to solve an inequality that you would to solve an equation. It's going to be that same idea for graphing inequalities. And then if you also remember, when you were solving inequalities, solving them like equations, when we graphed them, there were a couple things you had to think about, whether it was an open or a closed circle, and whether you shaded to the left or to the right. And it all depended on your symbol, whether it was a less than, a greater than, a less than or equal to, and a greater than or equal to. I only bring that up because it's kind of the same idea for this. You're going to graph it like a regular equation, but when it comes to the end, like connecting your line, and in this case we're going to be shading, it all has to do with your inequality symbols. Just like an open or a closed circle and shading left or right on a number line. Okay, so before even getting into an inequality, I'm going to show you how much this is like graphing an equation. Notice that first example for 147 is not in y equals mx plus b form, so we need to get it in that form for solving for y. Right now, y is not by itself because the plus 5 is in the way. So to undo that plus 5, I'm going to subtract 5 from both sides of my inequality sign, just like if it was an equal sign. So that's going to get me y, oops, I almost put an equals, is greater than, bring down that greater than symbol, And then this is, again, a literal equation. So I bring this down exactly how I see it. It's a 2x minus 5. So I write it just like that, 2x minus 5. Okay, I'm going to use the M and B method. M, for this one, remember M is in front of x, so M is 2. But I want it to be a fraction, so I'm just going to put it over a 1. And B is the number by itself, which in this case is a negative 5. Okay, so if you want to get ahead and start practicing graphing this line, go for it, plot the points, but don't connect them. That's the inequality difference. Don't connect them. We'll talk about it when we get there. I'm just going to go through this by starting at B. B is negative 5, so I'm going to put a point on negative 5. And then my rise over run is rising a positive 2, so that means up 2. And I'm always going to run right. In this case, I'm running right 1. So up 2, right 1, up 2, right 1. Remember, don't connect your dots once you're done. We'll talk about that in just a second. Okay, when you're done going up to right 1, you can continue your graph by doing the complete opposite, down to left 1, down to left 1, so that you have as many points as possible. I promise next week you will be happy you're getting in this habit. And I'm just going to jump up here to show you everything that's listed. So right here, you are going to connect your dots that we just made with a dashed line if it's a less than or greater than symbol, or a regular solid line like we've been doing if it's greater than or equal to, or less than or equal to. Okay, so a dashed line if it's less than or greater than, and you're going to use a solid line if it's less than or equal to, and greater than or equal to. So the difference here is the or equal to. If you have an or equal to, you're going to use a solid line. That's represented on your graph. So this symbol is just a greater than. Because it does not have the or equal to, it is going to be connected using a dashed line. So what I mean by that is just a dashed line, just like so. That's why I didn't want you to connect it right away. If you connect it with a solid line, that means that it's a greater than or equal to, and we don't have that. Okay, now going back up to talk about how to shade. So you are going to shade up if you have a greater than, or you have a greater than or equal to, and you're going to shade down if it's a less than or a less than or equal to. So this one doesn't have to do with the or equal to, it just has to do with whether it's greater than or whether it's less than. This one is a greater than symbol. This one is a greater than symbol, which tells me that I am going to shade up. So what I mean by shade up is you're going to shade everything that is above this line. So I'm shading every single point above that line. Kind of like towards the top of your graph. That helps you to determine what up and what's down. All right, for those of you that are struggling with that concept of up, there's something else you can do. It's called a test point. So to do that, we're going to actually first talk about a sample solution. So I'm going to just back up for a minute. That was too much information too fast. So going back to this equation before we got into inequalities, the solutions to an equation are all of the points on the line. So all the points we have drawn, all the points in between, every single point on this line is a solution to this equation. I'll say that again. Every single point on this line, all the points we drew and all the other points, even going on forever and ever and ever, every single point on that line is a solution to this equation. Now thinking back to when we had inequalities, for example, this one that's even stated up here, x is greater than 4. Remember what that means. If x is greater than 4, that means 4 is not included, but 5 is, 6 is, 7.5 is, 7.6 is. All of the numbers greater than 4 would be included in that inequality solution. So now that we have a line with an inequality, all of your points that are greater than that line are going to be solutions. So how many solutions do we technically have for this? Every single point that's greater than the line is going to consist of infinitely many points, meaning infinite solutions. Okay, so just a sample solution for this first graph we gave. All of your solutions are within the shaded area. And I'm going to redo my circle because I actually included the line and I don't want to include the line. Okay, so a sample solution for this one could be, I'm just going to pick this point right here, -4, +2 is my sample solution. All points are written as x, y. Remember, we just went over that in the table where the x value and the y value go together. That's a coordinate point. So x, y, your sample solution would be -4, +2. You could also pick this point right here, which is -8, 1. There's infinitely many points that you can pick. It just has to be within the shading. Okay, so some examples of points that don't work. Sometimes that kind of helps really reinforce the idea. The points that aren't in the shading. So this point right here, not a solution. Right here, not a solution. Right here, not a solution. Only the points inside of the shading. Now, something that's extra important for this one is that concept of a dashed line. The dashed line means greater than, not, or equal to. So when we just talked about this graph up here where every single point on the line is a solution, for this line, because it's dashed and because it's a greater than, all of these points on this line are not solutions, and I cannot stress that enough. All of the points on this dashed line are not solutions. So this one is also not, and so on, because of the greater than concept. So going back to a basic, x is greater than 4. If I drew that on a number line real quick. So here's 4, 5, 6. Remember, we would put an open circle around the 4 and shade where it's greater than. But the whole idea of this open circle means that 4 is not included. That's what the dashed line means. When you have a dashed line graphed, it means all of the points on the dashed line aren't included, just the points greater than. So I'm going to do the next example and go over that a little bit more with you with this one. So luckily this one's already in that y equals mx plus b form. Even though it's not an equals, I have my m and my b on one side and y is by itself. So I'm going to state what m and b are. Luckily for this one, m is also a fraction, so it's -1/4 for m, because that's the number in front of x, and b is a +3. So first, just graph the line like we've been doing this whole set of notes so far. I start on 3, and from there I'm going to rise -1. What does that mean? Okay, rising a -1 means I'm going to rise down, and then we always run right because that's a +4 on the bottom. So rising down 1, right 4, down 1, right 4, down 1, right 4. Go for it. Remember, don't connect it right away. Okay, down 1, right 4 only got me 2 points. Here's where going the complete other way does help. Going up 1, left 4 will finish out that pattern for me nicely. So I have a line that fits this whole grid. But the next thing I'm going to do is look at my symbol. The symbol for this one is a less than or equal to. So less than or equal to, the first thing I need to ask myself is whether it's going to be a dashed or a solid line. Because it has the or equal to, that means it's going to be a solid line. Just taking that information from up here. The solid line shows that it's part of the solution. And for this one, we're looking for all the points that are less than or equal to that line. Or in other words, less than or on that line. So I'm going to use a solid line to connect these dots. I'm going to try and draw it as straight as I can. There we go. So this one is a solid because of the or equal to. Then the next thing you have to ask yourself is whether it's shaded up or down. Because this is a less than that comes from this information right here, it's going to be shaded down. So it's a solid line and I shade it down. So towards the bottom of the graph when you're shading down. Okay, sample solution for this graph. Again, it can be any points. There's infinitely many answers, so you have a really good chance of picking one that's right, but your goal is to pick one from inside of the shading. I'm actually going to pick the origin, which is the point 0, 0, because it's inside of the shading. It's a nice point to use. But you could also pick this point over here. You can pick this point here, anything in the shading. So points that don't work for this one, again, up here is a no-no because it's not in the shading. Something that's a good point that wasn't a good point in the last example is this point right here. All of the points on the line are included in the solutions for this graph because of that or equal to concept. Almost as though, let's say I was doing x is greater than or equal to 4. And I graphed it on a number line. I have 4, 5, and 6. I have a solid or a closed circle still shaded to the right, but that closed circle shows me that the 4 is included, just like this solid line shows me that all of the points on that line are included. So if you wanted to, because this is a solid line, you could use this as a solution. 0, 3 is a solution to this one. This point right here, 4, 2, also a solution to this inequality. Okay, so I started mentioning something earlier, and I said let's just backtrack for a minute and talk about solutions. Something that you can do if you don't care for that shade up, shade down idea is use a test solution. So what I mean by that is you can test out a number. I'm actually going to leave that part there. Just erasing a little bit of this. I'm going to use this graph to show you. If you test out a solution, like you and I, oh my goodness, all of us know right now that 0, 0 is a solution because we already did this problem. But if you didn't know which way to shade it, okay, let's pretend we know nothing about this right now, which way we're shading. Okay. A nice point that you can always test is 0, 0. If 0, 0 works in your inequality, that means it needs to be included in the shading. If 0, 0 doesn't work in your inequality, that means you would be shading away from that point because it shouldn't be included in the solution. So what I mean by that is I'm going to take this inequality, and again, I'm working with this graph. I'm just using the space over here. So the inequality is y is less than or equal to -1/4 x plus 3. If you plug in or substitute in your sample point, which is 0, 0, that means you're going to put a 0 in place of x and a 0 in place of y. So 0 is less than or equal to, I bring down my -1/4, and in place of x, I plug in a 0 and bring down the plus 3. If I simplify this out, the left side's going to stay 0, the less than or equal to comes down. This right here, -1/4 times 0 is just 0, and if I add 3 to that, I'm going to get a 3. Now look at what we have left here. 0 is less than or equal to 3. That is true. I hope we agree. 0 is in fact less than or equal to 3. It's smaller than 3, so that is a true statement. Because 0, 0, when I plugged in 0, 0 to my inequality, because it worked, that means that the point, that means that the point 0, 0, this point right here, is in my shading. So that tells you that you're going to shade it down because you want that 0, 0 to be in your shading. Okay, some of you might be going, oh, that makes so much more sense than the shade up, shade down rule from up here. Some of you might be thinking that makes no sense. If this makes no sense to you, ignore I even said it. Just memorize this rule. If that helps you, I hope it does. Awesome, use that. If not, like I said, just ignore it. I like to show you guys a couple different ways of doing things to really help you out. 0, 0 is always a nice test point to use. If your line's going through 0, 0, that would be the one time where it's not a good point to use, but you can use any point. You could pick whatever, 9, 5. You can plug in 9 for X, plug in 5 for Y, and see if it works. If it does, shade towards it. If it doesn't, shade away from it. Okay, your code word for this video is blue. Okay, your code word is blue. And we're just going to do a little bit more on this page. So finding the slope between 2 points. Sometimes you're not given a graph where you can just count rise and then count run to figure out your slope, but you will be given coordinate points. Okay, so finding the slope between 2 points is what we're going to work on now, and there's a formula for it. So something I might not have mentioned yet, but definitely should, is if we use a formula in the notes, I'm going to provide it to you on tests and quizzes. So you don't need to memorize formulas in this class. All you need to know is how to use them. Okay? So when you're finding the slope between 2 points, you're going to be given 2 points. One of them will be your x1 comma y1. Your other point will be your x2 comma y2. And if you notice, those values are in your formula just like so. Whoops. Okay, where your second point and your first point just get plugged into this formula, and ultimately when you simplify it down, you'll end up getting your slope. Okay, so the directions just say determine the slope, so that's exactly what we're going to do. For 149, what I'm going to start doing is labeling as x1, y1, and x2, y2. Okay, it doesn't matter if you flip-flop them, making this x1, y1 and this x2, y2. That does not matter at all. It's entirely up to you which one you choose. Okay, so in my formula, I first bring down my m equals, remember, m represents slope, so that's the only reason that that's there. It says slope is equal to, I plug in my y2 to start, which is 15, bring down the minus from the formula and plug in y1, which is 3, over, on the bottom of my formula is x2, so my x2 is 9, minus my x1, which is also 3. Remember with PEMDAS, you have to simplify the top and the bottom first. So on top, I have 15 minus 3, which is 12. And on the bottom, I have 9 minus 3, which is 6. And now that I've simplified to this point, I can divide. 12 divided by 6 is just 2. So your slope for this first example between those 2 points is 2. So kind of what that means is if I plotted these 2 points on a grid, I could do up 2 over 1, up 2 over 1, up 2 over 1. And if I drew that on a grid, it would cross through 3, 3, and 9, 15. It's kind of cool. You don't even have to graph it. You can just use this formula and it's all done. All right, this next one, same idea with the x1, y1, and the x2, y2. I'm going to plug them into my slope formula. So m equals, first I plug in the y2, which is a 1, minus, be careful, very, very careful here. I bring down the minus from the formula, and then I have to plug in y1. y1 is a negative 3, so I have to write negative 3. We'll talk about that in a second, but you got to bring it down just like you see it. So bring down the minus from the formula, and bring the the negative from the y1, which is the negative 3. On the bottom, x2 is a negative 4. I bring down the minus, and x1 is 8. I do just what I did in the last example where I simplify the top first. If you're unfamiliar with minus and negative, you can literally plug into your calculator 1 minus negative 3. Remember, those are separate buttons, and it'll get you 4. if you remember what that minus and negative does, when you have a minus and a negative next to each other, they become a giant plus sign. So it's really just 1 plus 3, and that's where the 4 comes from. On the bottom, definitely use your calculator if you're not great with negatives, but negative 4 minus 8 is a negative 12. Okay, you can simplify this down in your calculator by doing 4 divided by 12 and then pressing math, enter, enter. Or you can just simplify the fraction down. They have a common factor of 4. So if I take that out, it'll get me a negative 1/3. That negative, oh, God, I think I did it like 8 times now. I'm so sorry. Almost there. Come on, there we go. That negative on the bottom can stay on the bottom. You could write it as 1 over negative 3. That's also correct. But typically when you see a fraction, the negative is written on top. So just try and get in that habit. It's not a big deal if you don't. It's still correct. Okay, last few examples here. 151 is really easy. What I'd like you to do real quick is just write out that y equals mx plus b. Okay, 151, determine the equation of a line with a slope of 5 and a y-intercept of 6. So remember, slope is m, your y-intercept is b. So we already have the information we need. Whenever you're writing an equation of a line, the two numbers that you always need are m and b. If you have those, you have the equation. So the y comes down, the equals comes down. My slope is 5, so that goes in place of m. The x comes down. And then the y-intercept is a positive 6, so I write plus 6, and that's the answer. Done, done, done. Okay, for 152, determine the equation of a line with a slope of negative 2, so that's m, that goes through the point 1, 5. 1, 5 is going to be like an x, y. So we have a problem for this one. I just told you we're all set with an equation if we know what m and b are. But in this one, we only know what m is. The problem gives you an x and a y value to help you find b. So right now, what we have, if we plug in for y equals mx plus b, is all we know is negative 2 is m. If I bring down the x plus b and all of that, that's what I have. But I'm still missing b. So when you are solving any equation for any variable, you can't have more than one variable in it if you want your answer to be a number, and we do. So that's why this point was given. If I plug in 5 in place of y and 1 in place of x, watch what happens. I'm going to do it off to the side. So 5 goes in place of y, just because that's what it was given as. The negative 2 comes down, and in place of x, I plug in a 1. And the plus b comes down. Notice I still have this b, but it's the only variable now, and I can solve this equation for b. So to do that, I'm just going to bring down the 5 equals. I'm going to multiply these together to simplify it. Negative 2 times 1 is negative 2, and the plus b comes down. So I'm still trying to get that b by itself. The only thing in the way of b being by itself is that negative 2. To move a negative 2 to the other side, I'm just going to add 2 to both sides so that that cancels out. And 5 plus 2 is 7. Don't get carried away. This is not the answer. Remember, we were trying to figure out what b was so that we could get our overall equation. Now, I know what m is. I know what b is. I can write out my equation. So my final equation is going to be negative 2x plus 7. I'd like you to pause the video right now and give this last one a try on your own. This is the last one we're going to do in this video. So determine the equation of a line that goes through the points negative 2, 2 and negative 1, 8. Okay, remember the two things you need when you have y equals mx plus b. To have a complete equation, you need m and you need b. This one gave you neither of those. It gave you 2 points. But let's go back to the top. You can find slope with 2 points by using this formula. Okay, so to use the formula, I need an x1, y1, x2, y2 in my formula. So I'm going to find slope first. using m equals y2 minus y1 over x2 minus x1. So plugging in my points, y2 from my labels is an 8 minus my y1, which is a 2, over my x2, which is a negative 1, minus my x1. Be careful, x1 is a negative 2. So I have a double negative there, and that's just going to become a big old plus sign. Okay, so I'm going to simplify this down. On top, 8 minus 2 is 6, and on the bottom, there we go, a negative 1 plus 2 is just a 1. So that just simplifies down to m being 6, and I have one of the things I need to have my final equation. Now I'm missing b. If you think back to the last example we did, where we were given the slope and we were given a point, we used this whole mathematical concept over here to find b. I'm just going to do that same thing again. So if you didn't do this part on your own, definitely pause the video now and give it a shot. It's the same process we just did in the last one. You can pick whichever point you want. I'm going to use negative 2, 2. So in my y equals mx plus b format, I now know that m is 6, and I have to use 2 for y and negative 2 for x. In doing that, I now have my b left over, and I can manipulate this and solve for b. So I'm going to do exactly what I did in the last example, where I bring down the 2, and I simplify this. 6 times negative 2 is a negative 12, and I bring down the plus b. And then to get b by itself, I have to get rid of that negative 12. To do the opposite of negative 12, I'm going to add 12 to both sides so that this cancels out. 2 plus 12 is 14, so I get that 14 is equal to b. Now I know this method seems kind of weird, but you're just using the information given and your y equals mx plus b format to help you find your ultimate goal, which is finding m and finding b. Now that I have those two numbers, I can write my final answer. My final answer is going to be y equals, remember m is 6, so 6x plus b is going to be plus 14. That's my final answer. This one's about as tough as it's going to get, where it doesn't give you the slope or the y-intercept, and you've got to do a lot of math to figure all that out. Okay, so y equals mx plus b is the big takeaway from today. Study those rules about whether you do a dashed or a solid line or shade up or down for inequalities. Remember, that doesn't even apply for equations, just when you have the less than or greater than, or the less than or equal to, or the greater than or equal to symbols.